Hello everyone, we're here in front of our 2014 GMC Sierra pickup truck, and I've got it outfitted with just pretty much every common sensor that we'll check with the scope. They're all laid out here. We got CAN bus, cylinder pressure, ignition primary amperage, the ignition control circuit, secondary circuits, a pulse sensor, cam and crank, and fuel injectors, the direct injection. On this side I've got battery, amperage, voltage, I got blower motor amperage. So I got a variety of things wired in here, and we're going to go through and check them on these 4 scopes. On the $400 to $500 MaxiScope by Alltel, it's hooked up to this first computer. The 6022BE Hantek, $60, hooked up to the middle computer. And we got a Pico 2204A 2000 series scope, which is going to run off Pico 6 on this end computer. And then the Pico 4425, which is an automotive scope, and it's going to run off Pico 6 automotive. And we're going to look at all these different sensors on all 4 of these scopes, and we'll see if they all have the ability to do the measurements that we expect them to do. All right, probably the easiest thing to check first would be the CAN bus. It's just 2 channels, but we'll go right across down the line. And for the first, can the Autel handle a CAN bus signal? You can see on this pattern here, it has no issues with it. You might look at it and say, oh, what do you mean? That's a horrible looking pattern. Remember, this one was at 10 milliseconds per division. So if I zoom in on that, you can see the CAN bus signals in there. It works perfectly fine. The Autel also, under the Tools menu, gives you the ability to do serial decoding. And when you enter that, you get the added benefit of being able to see the CAN bus messages at the bottom there. They don't tell you what they refer to, but you can look at them and figure out if it's a legitimate signal. Looking at the Hantek. So the Hantek, can it measure a CAN bus signal? And you might already be able to guess yes because of what you're seeing on the screen. And if I hit the play button, there's the CAN bus signal. I will change the speed at which it's showing so that way. So like right now we're seeing the CAN bus being displayed on the scope. You only get one screen, you don't get a waveform buffer like you do at the Pico. But once you pause it, you can kind of zoom in on it and out. You could do it not only vertically but horizontally. So this is like a voltage zoom, if you will, and that's the time-based zoom. So can the Hantek measure CAN? Yes. Will it decode? No. The Pico 2204A can also measure CAN bus. And just like the Autel, it does give you the ability to decode. And now when you look at this, you're like, ah, what a messy pattern once again. But if I pause it, take my zoom feature, zoom in on it, you can see the patterns there. Not only is the pattern there, you can keep zooming in on it. They also have a serial rate decoder or a CAN bus decoder, or just really serial data decoder. You can pick between a lot of different types of serial data, and it will go through and tell you what the code is. Doesn't tell you what it refers to, but it will give you an indication of whether or not that pattern is legit. Now if I switch over to the automotive scope, so can the Pico 4425A measure CAN bus? Well, of course it can. This is the powerhouse of the group, so it's not going to have any issues with it. You can see here, even at 500 milliseconds per division, I'm sampling at 200 nanoseconds. The sample intervals are 200 nanoseconds apart from each other, which is pretty impressive. And if I stop the scope and I zoom in, see that the CAN bus pattern is there. And if I keep zooming, not only is the pattern there, but also I get to see the hexadecimal code and so forth. It even gives me a little pop-up menu or pop-up showing of the the data for each one of those messages. So it doesn't tell you what that message refers to, but it tells you once again if it's a valid CAN signal, if it converts to hexadecimal, which means that not only do you have the ability to look at the pattern to see if it's good, but you also have the ability to go through and see if it's decodable. So yeah, all 4 of these scopes have no issues running CAN bus. So don't let that be a distractor of buying a cheap scope by itself. Probably one of the most common measurements that people think of when they think of scopes is measuring cam and crankshaft and checking the correlation between the two. So I have the Autel hooked up here with just cam and crank. And you can see I'm at 100 milliseconds per division, plus or minus 20 volts on each channel. And the channel A looks pretty thick, but because it's a 60 pulse, I believe, signal, if I zoom in on that, you can see it does a good job of measuring my cam and crankshaft position, as we would expect. So we can see with the Hantek, I went ahead and paused it. It also does a decent job. If I spread that out somewhat, it's doing a fine job of really picking out the cam and the crankshaft position sensor. Not a struggle. I'm going to switch over to my Pico 2204A. I'm at, let me change this down to 100 milliseconds per division, make it the same as the other scopes. Turn off my resolution enhancement that I had on from before. You can see it also does a good job of showing the cam and the crankshaft. Okay, with the Pico 4425, I've got my cam and crank shown, and it does, as we would expect, a really good job. We zoom in on it. I did struggle with the ground issue that was causing the pattern to wave around quite a bit, but it looks like I got it resolved. For doing some of these measurements, I have some of these signals grouped up into common measurements. And I'm going to go through ones that maybe just have two, so that way I can just utilize the two channel scopes and not have to kind of double up on some of the measurements at first. So I'm going to go ahead and do the battery and starter right now. We've got the Autel hooked up, and I've got the channel A is hooked up to battery voltage, and channel B is hooked up to the amp clamp, the high amp current clamp. And I can drag my little cursor down here. Now this is one thing I found is difficult with this Alltel, is actually grab their little horizontal rulers. So this one here is showing, looks like we've got 115 millivolts, so 115 amps. And then we could see the voltage level while cranking it. I gotta like be on the outside edge of these squares to get it. So cranking voltage, it only dropped to 11.68, so our battery is pretty good. It cranked over a nice rate. So this thing does a perfectly fine job of measuring amperage, perfectly fine job of measuring voltage, as one would expect. It's probably not that complicated of a measurement to do. Switch over to the Hantek. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 4, 5, 6, 7, 8. Yes! I got it! Yeah! Whew! Okay. So now that we did the Hantek measurement, we're taking a look on the screen of what we see. A couple things that are odd, that don't make sense. As you can see, channel A is supposed to be measuring my voltage, and I have it set at 5 volts per division, and this is a division right here, and it looks like if this is the 0 point, we're only getting 5 volts, which that can't be right. The other thing is channel, let me get rid of my cursors here, if that'll do it. It's supposed to. It's not doing it though. There we go. And channel B, which has my amp clamp on it, it's 50 millivolts per division, so 50, 100, 150. So it kind of shows maybe 150 millivolts, 1 amp per millivolt at 150 amps. Okay, that's probably believable. So now we'll see if the Pico 2204A can do battery amperage and battery voltage, determine the quality of our starter and our battery. Getting about 168 amps, and my battery voltage drops down to 11.53. So yeah, we don't have any problems with the 2204A doing the job. So we could see with the 4425, 162 amps and 11.62 volts. So all these scopes don't have any, all these scopes work perfectly fine doing this test. Next on the list is the ignition system. We're going to check the secondary and primary. And channel A, I'm going to go ahead and have that be my secondary voltage. And this is the lead that clips around the spark plug wire. Channel B is going to be amperage. And because this is a coil that has an igniter, it doesn't have, it's not 2-wire coil, the coil and plug assembly. It's actually 4 wires. So they've got power, a ground, and a little 5-volt trigger signal to it. So instead of watching the primary voltage, which we would need an attenuator on all these, we're just going to check the amperage flowing into it. So that's what channel B is going to be. So we're going to look on our Autel first. So this is upside down. So I can either create a custom probe for the inverted version, or on my math channel, I can just invert channel A. And it will show me what it looks like. So I'll use this blue as an indication of the secondary. I can also change my scaling because I'm at 20,000 volts, maybe 10,000 volts will give me a little better look at it. I could try to drag this one off the screen a little bit because it's not facing the right direction. So here I got my amperage and I've got my kV. I'll go ahead and stop that. Now if I go to my zoom window, I can zoom in on that, those two patterns. And you can see you get a pretty decent secondary pattern. Remember, hit the arrow up top if I want to select something down there. I would think that that would be a nice little software improvement for Alltel to do. If they see you over on the side, this is what Pico does, if they see you over on the side, they pretty much know that you're looking to drag these rulers around. It should automatically switch over to that. So my time-based ruler, that's also kind of odd. It's only giving you in the, it says 2 milliseconds and it's rounding it. It's 2/1000ths of a second, which is 2 milliseconds. So it'd be nice if they gave me a little bit more, because it could be 1.51 or it could be 2.49, you know, so it'll still round it down to 2 or round it up to 2 depending on where you're looking at it. So it'd be nice if they gave us a little bit more clarity on that. And I'm sure it would if I had this running at a different time base. This is my trigger settings. If I do it on the fall, it should, there we go. So this does a little bit better job of showing us the ignition pattern, and we can see with more accuracy what our length of our spark is. It's 2.342 milliseconds. No problem checking secondary on the Autel and primary amperage. We probably suspected that, but and then if you, like I said, if you raise that up to you know, 100 milliseconds per division, you can do a comparison of your firing lines. Let's move over to the Hantek. I'm going to go to 2000 volts. The lower I can get this, the better clarity, and the bigger the image I'll get on the screen, the better the clarity I'm going to get on my pattern. And for better or for worse, that's just how these scopes, these 8-bit scopes are going to kind of react for us. So if I pause this and expand it out, get my cursors off of there. I'm dragging this over so I can see one of these. That's my secondary pattern. It looks good on the amperage. I can do a pretty good job with the amperage, and if I use my time cursors, let's see if it'll do a good job measuring the length of that spark. This is 2.3 milliseconds. That was accurate. The kV I wouldn't trust. Yeah, we can see it. I don't know if it's the best, but it is definitely viewable. Let's move over and take a look at the Pico 2204A. Now remember with the Picos, you have to be between 100 milliseconds and 500 milliseconds to be able to sample at 1 microsecond division intervals. Take a look over here, it says 1 microsecond per division. If I go below 100 milliseconds per division, that number, the interval number just, went up 163 times. You can see the quality of the pattern, it's not even picking up the firing line. If I go up back to 100 milliseconds, now I can see firing lines. I'm still at 1 microsecond per division. At 200 milliseconds per division, I'm still at 1 microsecond of sampling interval. If I go up to 500, then it goes to 3 microseconds. And you can see, like right here, it loses some of that firing line. See how that drops down real low? That's probably not real life. So if I back up to 200 milliseconds per division, this is going to be more of an accurate representation. Now this is one of those situations where you're going to want like an 8-bit scope, so you're going to want to make this pattern as big as you can, and then if anything, shrink it down. So we'll select maybe 10 kV, and then under our zoom, reduce it down so that way it doesn't take up too much of our screen. We don't want it to go over, like it'll say channel overage. That means it won't ever show you above 10,000 volts if we're in the plus 10,000 volt scale. But okay, I'm going to go ahead and pause this and back up a page. So this is the pattern that we get on the 2204A. Amperage is fine. It's just not really that bad. You can see the spark line and the firing line okay. There's the firing line. It's about 5,000 volts. And the spark line, it's floating there at about, oops, I dragged the wrong one. That's the amperage. The amperage is about 8.6. So all those measurements look accurate. This is the spark line is at about, well, this says 335 volts. And remember, this is measuring off the spark plug wire, so. And, well, you can see the length of my spark is about 2.206 milliseconds, so the length is fine. The only issue that we really have is the clarity, and that's the downfall of the 8-bit scope. If you try to look at the clarity of an 8-bit scope, you'll see a lot of that jumbling up and down. That fine vertical resolution is where the 8-bit scope will suffer. So this right here, but you can still get a decent pattern, decent enough to interpret it. It's just not going to be as nice as a 12-bit scope. The difference between 12 bits and 18 bits is the difference between a scope image that has 256 points to fill in data versus 4,096 points to fill in data. So you get 16 times more resolution on a 12-bit scope than you do on an 8-bit scope. If I switch over to my 2204A, as you can imagine, it's going to be probably a glorious looking pattern. So I've got it still set up. Matter of fact, I've got this set up at -5 to 20,000 volts. If I go back to the same scale that I was at on the 2204A, and then we pause it, you're going to see it's a much nicer quality pattern. Get a little bit, matter of fact, the resolution's so good you can pick up noise a little bit more. But the same measurements will probably come out to be about the same, 2.2 milliseconds, 8 amps, 4.23 kV. The Pico, obviously the 4425 does it. All the scopes will do it. The 4425 does it better, the MaxiScope does it better than the Hantek or the 2204A. So next we're going to check gasoline direct injection. We're going to check the power going to it. And I'm using a 20-to-1 attenuator. The scope says it has a maximum input of 100 volts, but I'm not going to take my chance. I'll go ahead and put the attenuator on, it really doesn't matter. And then the amperage, the amp clamp, I got a 20 amp clamp hooked up to it. So we're going to go ahead and start and see what this pattern looks like. I have the scope set up right now. As we can see, it's at 20 volts per division, so 100 volts plus or minus. And then I've got 1 amp per division, so I've got 20 amps plus or minus. So right here I've got my Autel hooked up. I'm checking the power side of the gasoline direct injection on channel A and the amperage on channel B. On channel A, I've got the attenuator hooked up to it. That's a 20-to-1 attenuator. It knocks the voltage down 20 times. So 20 volts in is 1 volt out. And if I tell my scope that, if I do that down here, I could say it's got a 20-to-1 attenuator on it, then it corrects the scaling for me so I see the proper numbers on the side. And then for amperage, I got my amp clamp hooked up and I got a 20 amp scale on it. So you can see right now these GDI injectors at 100 milliseconds per division, it's doing a decent job picking that up. If I pause this, click my zoom button and zoom in on just maybe one event, I can see with clarity, I can see the voltage kick up. Gotta click my arrow, I always forget to do that. About 60 some odd volts, 66 volts. And the amperage, about 15 amps. Does a good job of checking it. That's the Alltel. This is the Hantek, and remember I was having issues with the Hantek. Now, the Hantek is a little different because they don't have a 20-to-1 drop-down box. I can select the 10-to-1 attenuator probe, you can see here, where if I select 1x, then that's just 1-to-1. And I could select 10x, or 100x, or 1000x, all that stuff. And the leads that the Hantek comes with has a switch on the side where it's 1x and 10x. So I know you probably can't see that too well up there in the corner, but there's a little switch where my index finger is. So if I were to check this in the 10x scale, which I just have the lead selected to, then I'm going to go ahead and use my amperage for what it's worth. It's 1 millivolt is 1, or 100 millivolts is 1 amp. And you can see my amperage is already coming in. 1, 2, 3, about 16 amps maybe if I zoom in on that. Okay, well I can see a pattern. Let me drag channel A up. And I'm at 50 volts per division. Let me pause this so that way I can unhook it and get it out of the way. So if I kind of zoom in on that horizontally, you can see it does a decent job. Now I don't think my voltage is still accurately represented. I was supposed to be getting about 66.5 volts. And if we put some cursors on there, it's showing 44 volts. So I think something's up with this scope. It's not showing me the proper voltage. Now we're hooked up to the Pico 2204A. I've got my 20-to-1 attenuator on channel A, and I've also got my amp clamp in the channel B. So right now we're seeing 100 milliseconds per division, amperage on B, voltage on A. It looks like we're getting a decent pattern. If I stop it, I can zoom in, and I can see with relative clarity that pattern. Pull my voltage cursors down, you can see about 66 volts, about 16 amps. So the Pico 2204A does not have a problem measuring GDI voltage and amperage. And as we would assume, Pico Automotive, we don't even need the attenuator on that, but I'll just leave it on since I've been doing that with the other tests. If I reduce this down so it doesn't take up as much real estate, we zoom in on a pattern. Looks pretty good. Drag our rulers down, 65, 66 volts or so, and about 16 amps. So all of these tools have the ability of producing this pattern. The Hantek on channel A, for some reason the voltage is off. But other than that, all 4 of these scopes do not have any issues showing the pattern. And I have a feeling that I might have an issue with the Hantek, either the software or the scope, as far as the voltage is concerned. Next, we're going to check relative compression. And the way I have the scope set up right now is channel A, which is measuring the ignition control voltage. It's got 20 volt scale. Channel B, which is measuring battery voltage, is a 20 volt scale. Channel C is measuring the amperage, and it's the 500 amp clamp I've got on there, or 600 amp clamp. It's in a 500 amp scale. And then the pulse sensor, which I just picked plus or minus 5 volts for it. So I can go ahead and I'm going to zoom in on this section where it seems to be most stable. So this is the amperage, and each one of these pulls, each one of these where the amperage climbs, is going to be a cylinder coming up on compression. And just going off the ignition pulse, assuming that's pretty close to top dead center, I can drag it towards the ignition pulses there. And you can see, so like if this would be cylinder number 1 coming up on compression, and the next cylinder. I've got 8 rulers up there, so each one represents 1 cylinder in this engine. And if I had a cylinder that wasn't contributing, I could see it right there. Using amperage, it doesn't have a problem measuring relative compression, and I can see the pulses and the ignition coil. Now, you can't actually check relative compression using voltage if you don't have an amp clamp, but you can see right here, this top line in green is my voltage, and I'm not getting enough vertical resolution, and I can't zoom in on that image alone without zooming in on every other. But my point is if I zoomed in on that signal, I'd probably see those pulses. See, those pulses look similar to the amperage pulses. But unfortunately, unlike Pico, I can't zoom in individually on those pulses. There is a workaround though. You're going to end up, let me just go back to 100% zoom. Instead of having channel A on DC, I'm going to switch it to AC. And instead of it being on 20 volts, I'm going to make it maybe, let's see what 2 volts will do. And I'm going to crank this engine over. Now I have to crank it over and let that voltage stabilize, because what AC does, you can see, it gets rid of DC and it just shows you the alternating pattern. And so since I'm plus or minus 2 volts on that whole screen, how that battery voltage fluctuates while it's cranking is going to be displayed, not the DC voltage. Now I'm going to go ahead and zoom in on this pattern. And if you take a look, now I've got everything with decent amount of resolution. And really, if anything, it shows you how amperage and voltage, remember blue is amperage, green is voltage, and if I could clean green up, that would be nice, but like I said, for some reason, that low pass filtering doesn't always work. If you use battery voltage in AC scale on this scope, you could, especially if the filtering worked, you could invert that, or you wouldn't have to, but it would look the same as the amperage if you inverted it. Either way, you can see the cylinder's contribution by looking at voltage as opposed to amperage if you don't have an amp clamp, or your amp clamp battery died and you didn't have a fresh battery for it. Okay, so I'm going to switch over to the Pico 4425. Let's see what we got here. So, channel A, I got my ignition control. Channel B, I've got voltage. Channel C, I've got amperage. Amperage, and then on the bottom, channel D is my pulse sensor. And I zoomed in, and I'm seeing pretty much one full event. Similar to the Autel, I can do my rulers on my ignition events to kind of get an idea of when to place that, where to place that. Under rulers, I can increase my rulers. So you can see my amperage right here, up, up, up. So every one of these is going to show it. If I wanted to zoom in on the amperage to kind of get it to stand out more, I can click the little box down there and zoom in just on the amperage. I can clean up the amperage by selecting either resolution enhancement or active filtering, one or the other. I don't want to do both, or I can't do both. And here's the interesting thing, something that you can do on this Pico that you can't do on the other scopes. On the voltage, I'm going to zoom in about 9 times. Seems like a lot. Watch this, when I drag this down, if I filter channel B, those little squiggles on there are probably because I have a battery charger on this, but if I were to guess. So taking a look at this, you can see that the voltage and the amperage are pretty much showing the same thing. My point is if you don't have an amp clamp, you can usually still get away with doing some of these measurements without a amp clamp just by using voltage, like on relative compression. All right, now if we were to look at the Pico 6 and the 2204A. Let's look at ignition control first and battery voltage. Assuming that we're flat broke, we bought this cheap scope, and we don't have enough money to go out and buy an amp clamp, and can I still do this test? So I'm at 1 second per division. I do get my ignition pulses fine. That 8-bit resolution really screws this up. If I tried to zoom in on the voltage scale, you're gonna see it's gonna look really, that doesn't really tell us anything. But similar to the Autel, if I select AC, back up to our noisy slide, then if I apply some filtering to it, oh, that doesn't look so bad anymore, does it? Now I've got a pattern I could use for relative compression, and that's based all off of voltage. I'm just still zoomed in 4 times, but so that's actually not so bad. I can look at the contribution of each cylinder. Every time voltage goes down is when a cylinder is going up on compression. So I can use voltage, no problem, as long as I understand the filtering and I'll understand that I check it in AC. The other 2 channels, pulse sensor and battery amperage. Battery amperage will probably work great for us. The pulse sensor, we can actually keep the pulse sensor at 2 volt range. I'll switch it back to DC. Actually, I'm gonna move it to 5 volts. It pulses a little bit more. And the amp clamp, set that up to our, well, it's I don't have an amp clamp loaded, but it's 1 millivolt per amp, so it's pretty easy. The amp clamp did well. See, the vertical zoom does not like that as much. The pulse sensor shows up fine, and that was I should turn my, that's what it would have looked like without cleaning it up. So yeah, it works. 2 channels, so I'm stuck with, you know, if I want to synchronize that to a cylinder event, I can get the amperage and then maybe an ignition control or pulse sensor ignition control, but I can't do more. All right, got her. Whew. Scope's got me running. All right, so you can see I do have the ability of checking the amperage, and we could see a pulse. I didn't really crank it very long because I didn't want to miss the pattern. I wish there was a way to get to the beginning of this a little easier. I just stretched this out, but there's my pulse sensor and there's my amp, so it seems to do a decent job at that. You have to be set at AC to get battery voltage. They do sell these little adapters. They're capacitors basically that you could put in line with your scope lead, and that will ignore all the DC voltage and pass through just AC. The reason why we need this for the Hantek is because the Hantek doesn't give you the ability to select AC on the software. So you have to physically block DC voltage and pass only AC. So this is basically what that tool is. It's just a AC filter, it says. And it's a banana jack, so I'll just put this in line with my alligator clip. Just like that. I gotta catch it before it changes. Pause. Yes! A little fuzzy. I can still see the contributions there. Probably not the best, but $60 scope. All right, we got the Autel hooked up to a PV350 Fluke with ignition control. I actually have a dedicated battery or cable just hooked up to the PV350 because that helps take the noise away, helps. And also the pulses, intake pulses. Now we're gonna try this low filtering again. I'm hoping that it works because you can see we still have a lot of noise on channel B. Oh yes, see, now it's working. I don't know why. It has a mind of its own, but it's working. I hate to waste a lead, basically, or a channel. I literally just have it hooked up to the metal on the sensor. So I'll go ahead and pull that off. We'll run that again, or keep it going. So even with filtering on, if I take those off, actually not too bad. Oh, there it goes. The noise, the hair kind of grows on it. This is the ground lead hooked up to the body of the Fluke PV350. and that cleans it up. We'll zoom in on all of that and just pick one cylinder event. Then we could put our rulers up there. Now I can go peak to peak and make that 720. Not that that's real essential, but there is 2 crankshaft revolutions between peak to peak. And if I get rid of some of my rulers there, oh, I got 4, so this kind of roughly shows me the power, exhaust, intake, and compression. And I could see my ignition event, what would have happened right when this went from high voltage to low voltage, and I could see the individual contributions. This is probably, well, obviously the intake stroke is right here, because we still have our valving is working properly, but we have a misfire now on cylinder 1, so that might be the effects of that. MaxiScope does a fine job of showing the PV350. Now we're going to look at the Pico 4425, since it's a 4-channel scope as well. We've got our 4 leads hooked up there. I've got the Pico set up. I'm going to start the vehicle up. Now I'm going to show you a couple things I had to do with this Pico. One is, since this 4425 has it's a differential scope in a sense. It has a discrete grounds, so you can actually hook the grounds up separately. Most scopes, the grounds are common between each of the channels. So if you hook one ground up, you actually kind of hook them all up. You can even see on a lot of them, they'll draw a line between all the different channels and then draw a ground symbol. So that's a big clue if you see that all the grounds are the same. They don't do that on here. They say the grounds are different, plus or minus 30 volts. So your grounds, as long as the voltages are, or the ground level voltages are within 30 volts of each other, they'll be separate. They'll act as if they're separate. And because of that, they've got this little lead on the back where you can ground it out, the actual box, I guess, to help reduce some noise. And I've got to do 2 things when I'm working with this scope, or most of these scopes. These Fluke PV350s create so much noise. Sometimes I have to have a separate channel and just hook it up to the body, the actual pressure transducer on the Fluke. And in this case, that didn't cure it, so I actually had to take a jumper wire off the back and ground it out to the actual pressure transducer body as well. And you'll see what I mean here in a second. Right now I've got filtering on this scope. If I turn the filtering off for that channel and run it, you can see it, and I'll zoom back out to 100%. You can see I've got quite a bit of noise. If I take this ground lead off, you can see even it gets hairier. If I take that 3rd channel, channel C that I have just grounded to the scope, if I take it off, it gets, well, actually, it's kind of changed around in its own little way. I'm not really certain what all it did, but it likes it better with it plugged in. So between dedicating a channel to grounding out my Fluke and then taking the jumper wire and grounding out my Pico to the Fluke, that seems to make the pattern the least messy and noisy. And yeah, we do have this noise going on in the signal, and we can get rid of pretty much all that by using filtering. So here I'm zoomed in. I can zoom in on just the PV350 channel, the pressure transducer channel, make it bigger. I love that feature that Pico has with their software. And then, like the Autel did, I've got the rulers that I can put on the compression peaks there. And then I can add my rulers to kind of make my 4-stroke cycle going on there. Power, exhaust, intake, and compression. And there's ignition. With the Pico WPS, probably don't have to go through all this rigmarole to get the noise out of it. I don't know, don't have one. But you can still get a decent pattern to evaluate by just looking at this. So here I got the 2204A. Channel A is the PV350, which is in blue, which got a lot of noise. Channel B is the ignition control. And I just hooked up basically a lead that connects to the pulse generator, which we're not using. We're getting a pattern. It is still quite noisy. If I add filtering to it, So once it collects the data, it cleans it up, collects it, cleans it up. We'll go ahead and pause this and see how good this looks. Actually, it looks really good. The pattern looks nice and clean after we added that resolution enhancement. Pico 6 still gives us the ability to utilize those the rulers. So we can see the power, exhaust, intake, compression. The 2204A did a decent job, but that filtering saves it. If you didn't have the ability to filter, it'd be a lot harder to get this done. Now we can see if this Hantek has the ability of doing it. Since this thing has a lot of noise and I've got ignition control and PV350 hooked up, they do on the signal generator have a little spot where I can hook up a ground lead. And I might take the ground, and let's see if that ground makes a difference. So I'm hooking up the PV350 pressure transducer to the little ground lead on the Hantek. And you can see it improve the pattern quite a bit, but there's still quite a bit of noise. Unfortunately, we don't have the ability to clean up that pattern anymore. But let's pause that and then see if what we can do with it. Unfortunately, this pattern's got so much noise, I don't really think that'd be real beneficial to help diagnose engine mechanical. You can see when compression's happening in relationship to ignition, and but you really can't get a good idea of the exhaust and the intake and the compression and all that, unless you found a way to clean up this pattern so that way it didn't have as much noise. I would say every one of these scopes except the Hantek would do a decent job of checking engine mechanical. Another thing I do with these scopes is I use these $20 eBay transducers. This one's 1,000 PSI, but most of them I use are 500 PSI. And I use my scopes to kind of plot out pressure in transmissions or whatever, anything I need pressure readings on. So let's go ahead and use the Alltel and take a look to see if how well it does. One thing to note that these things aren't a one-to-one relationship. At 0 volts, this thing is actually measuring like negative 15 PSI approximately, I don't know for sure. Whereas at 0.5 volts, this thing is flatlined at 0. It's supposed to be at 0 PSI, and then at about 4.5 volts, it's supposed to be whatever it's rated at. So the one I have on the vehicle right now is a 500 PSI transducer, so at 4.5 volts, I'm supposed to have 500 PSI. So that means I can't just put this thing in the millivolt scale and just say 200 millivolts is 200 PSI. It's not going to be linear like that. And most of these, the Pico and the Alltel do have the ability to set up a custom probe. The Hantek does not, so it's really going to be limited on what I can do as far as using a custom transducer like this. So looking at my Alltel, if I go into Tool, Custom Probes, and I create a probe, I'm going to call this eBay transducer. And the unit's going to be volts, or actually the unit's going to be pressure. And I'm just going to put P for, because it doesn't let you do, for some reason, 3. I'd like to do PSI, but it only lets you do 2. So I'll just let it be at P. And then here's our equation. Y is equal to slope times offset. And the slope is how many millivolt change per PSI you got. And if it was 1 for 1, you just leave it at 1. But since this transducer changes more pressure per millivolt, because really the 500 volt range is between 0.5 volts and 4.5 volts, so it's a 4 volt sweep dealing with 500 PSI. So what we put in there is 1.25, because for every 1.25 PSI change, I change 1 millivolt. And now my offset, since 0 volts isn't 0 PSI, I need to put something in there to reflect that. And I found with this, if I put negative 0.65, that pretty much takes care of that offset. So now at this point, I got a transducer in there. Now that I have this custom probe set up, I'm going to select the range. Seems like the best working range I have is negative 6.9p to 5.6p. It looks like there is a offset or kind of a misplaced decimal. You don't have the ability of changing the ranges in Autel like you do on Pico, so you're kind of stuck with what you've got. But you know, here I am still able to graph this pressure over time, and using bidirectional controls in my scan tool, I can go ahead and change this pressure. That's as high as it'll let me go. I can drag my ruler and find out what kind of pressure I'm getting. This says 250, pretty much 250 psi. My mechanical gauge does agree with that. So it is a way to let your scope go through and graph the pressures that you're getting in this transmission. Let's move over to a Pico. Here we're looking at the Pico 2204A. The process is going to be very similar with the Automotive Pico. So we go to Tools, Custom Probes, New Probe. I want to use a custom unit defined. I'll call it pressure, PSI. Next. Now I can use that same equation that I used on the Alltel, or I can use this lookup table. I like using the lookup table because it's a little bit easier. In this case, 0 volts is equal to negative 15 psi, and 0.5 volts is equal to 0 psi, and 4.5 volts is equal to 500 psi. Okay, next, it's going to say, do I want them to set the ranges up? I'll do advanced manual because they'll set up so many ranges. Like if I hit auto generate ranges here, most of these I'll never use. So I'll just go ahead and delete all of them except for maybe that one and create a new one that goes like maybe between negative 5 psi and let's say 200, we'll say 270 psi. Or 260 psi. Gives me a warning saying that these aren't, you're not using much of your available range, but that's okay. I can apply filtering if I wanted. I'll call this eBay transducer. And finish. Now when I put my, now I go to my probe selection for that channel. In the library, you'll see eBay transducers listed there. And then you'll see my scales, that the negative 15 to 500 psi and the negative 5 to 260 that I created. Kind of defaulted to the 5 milliseconds per division. If I set this to 5 milliseconds per division, kind of like I did on the Alltel, you can see I've got my pressure coming across, do my bidirectional controls. Kind of nice to be able to see pressure over time as opposed to just looking at it on your mechanical gauge. You can go for a test drive and every time a transmission shifts, see if pressure drops out or so forth. But so this, the 2204A does a great job of measuring pressure. If you pause this and zoom in, yes, you will be dealing with the 8-bit resolution issues that we have that kind of have plagued, I guess, this cheaper scope. But as far as trying to determine what pressures are, if you kind of put your line in the middle of that, you'll likely get a decent reading. So it was 97 psi when it was just sitting there. And that matches my mechanical gauge perfectly. So let's switch over to the automotive scope. The Pico Automotive is similar. I will have to go through and set up a custom scale. So under Tools, Custom Probes, I could export it and import it, but it didn't take long to create this. All right, now that I've created the custom probe in the Pico Automotive 4425, I will select it in the library. So now we go ahead and start the scope up. I've got 5 milliseconds per division, which doesn't make much sense, so I'll switch that to the 5 seconds per division. And just like the other Pico, I can change my pressures. Scanner's moving a little slow here. Looks like it went over range there a little bit, a little higher than normal. But the Pico definitely had the ability of going through and doing this, the Automotive, as we would expect. We can drag our cursors to see what kind of pressures we're getting. And yeah, it worked perfectly fine, no issues. So the Picos, with their custom probe, especially with the ability to create a table and then create your own ranges, it by far works best if you've got a custom transducer. The Autel's not bad, but the custom ranges are kind of frustrating to deal with. Let's see if the Hantek can show us what we need to see. I'll set the Hantek up to about 5 seconds per division. Now remember, the disadvantage of the Hantek is that it records, basically in this case, it's not really practical to do it this way because it's going to record 50 seconds, then show me 50 seconds. And we just don't know what's happening during that mode. So if I set this at a faster time base, like maybe 50 milliseconds per division, at 50 milliseconds per division, we're going to update the screen at roughly every half second or so. With the issue that we have with these transducers, where a half of a volt is 0 psi and 4.5 volts is 500 psi, and it's not a one-for-one relationship there, it's going to be very difficult to translate what we've got on the scope to an actual pressure. But what we can do is maybe just check to see if the pressure is changing as we're expecting it. So if I'm commanding this up, we can see if the pressure is climbing. And so it does show us that, but it's going to be real limited in all diagnostic or practical senses because we really don't have an idea of what the pressure is. And unless we have the ability of measuring pressure, I don't really know what the point of having this pressure transducer would be. In summary, most of these scopes can set out to measure all these different circuits that we use in automotive. Some of them are a little trickier than others. The PV350 is probably, or the pressure transducer. Pressure transducers, you're probably going to want to have an Autel scope or a Pico scope. The Hantek, I don't think will quite cut it. Also, knowing when to use AC to get the better resolution signal will help you in some of the things like relative compression or checking ripple in an AC pattern or something like that for an alternator. But really, any one of these scopes would do a good job. If you're just getting into the scope, and I'd almost say having the 4 channels of the Autel would really be beneficial. If you don't think you need all 4 channels, you can't really be $140 in getting this 2-channel Pico. But eventually, if you use scopes quite a bit, you're going to want to step up and probably get that 4425 or the newer 4425A that has the powered adapters for your different leads. So it's got a BNC Plus connection. It's a little fancier setup, but hopefully you got something out of this. And if you have any questions or comments, just feel free to post them up and I'll see what I can do about answering them. Thank you.